We will experience future sea level rise. The question is just when and how much.
Our goal is actually, with these 3 expeditions, to put much better numbers on the northern Greenland ice sheet's future in the context of sea level rise. In August 2024, we will go out with Swedish icebreaker Odin. We will start from Thule in northwest Greenland and go northward all the way up to northern Greenland. There is a fjord called Victoria Fjord, where one of the larger outlet glaciers drain the northern part of the Greenland ice sheet. Victoria Fjord has never been explored before. The reason for this is because you have very difficult sea ice conditions in the Lincoln Sea outside of the fjord. And in the fjord you have very large icebergs floating around. So there are many challenges to get here.
There hasn't been anyone else there before, and there will likely not anyone be going in the near future either. So we have all the field there for us to conduct the work, and whatever we do, it will be excellent and novel.
The red thread through this expedition is the marine cryosphere. And the marine cryosphere is all ice that is in contact with the ocean. For example, sea ice, outlet glaciers that drain the ice sheet, and also permafrost at the sea floor below water. The whole interaction with the ocean makes the marine cryosphere, from a scientific perspective, very interesting to investigate because there's a lot of action. But from a climate perspective, it's also very important to understand it, because if the climate becomes even warmer, changes can happen very rapidly with the marine cryosphere. The 3 glaciers that we have been focusing on is Petermann Glacier and Ryder Glacier and Ostenfeldt Glacier. Petermann Glacier was the target for 2015 expedition. And one of the very big interests for Petermann Glacier was that it has lost a big portion of its floating ice tongue in 2010. Then it lost another part in 2012. So the whole reason why it lost this large portion of this floating extension of the glaciers was a scientific question. Turns out that we have Atlantic water that comes in towards Petermann Glacier and actually melted from below. Ryder Glacier, meanwhile, has been much more stable. It was much further out with a floating ice tongue in 1917. We know that from historical maps. But then it lost a big portion of it, but it's been fairly stable over the time when Petermann lost its ice tongue. It turns out that Ryder Glacier is partly shielded from a big bathymetric sill in front of the glacier that actually prevents the water, the warmer water, from coming in. And now we're targeting Ostenfeldt Glacier, which actually more or less completely lost its ice tongue in 2002. And that means that we have 3 glaciers that behave very differently, and they're all different reasons for why they have behaved different, and that's one of the main questions for us.
So this is instruments really like our eyes when we're offshore looking at marine sediments. You know, without it, we would just have tubes of mud. We got to just sort of double check that nothing's a little bit faulty or anything, because once we get it offshore and pack up and bring it there, if anything breaks, we have to sort of fix it ourselves.
Tjena! De är ganska tunga alltså. Det blir lite att bära för dem då, som vill ha så lätta prylar.
Ja, alltså den här ska vara 15 kilo när den är klar.
The sediment cores are like an archive over the past history of these glaciers. In Ryder Glacier, for example, we know that the large part of the glacier was all the way out to the fjord entrance about 12,000 years ago. And since that, it has retreated all the way into where it is today. So that's a part of this. We're going to look into the sediment archives and get maybe as far back as 15,000 years and started to then look into the change of the marine cryosphere.
The data has huge value in itself because it is data from an environment that hasn't been studied before. The second importance of it, and that is just as important as the first one, is that it is used to calibrate numerical models. Because any observations can only be as recent as today. We can have observations from yesterday and the day before and today, but we cannot make observations of tomorrow. So to look into the future, we need numerical models. And in order for those to be really good and reliable and give good predictions, we need to calibrate them. And this we do with data from today, yesterday, and the past. So the more data we have, the better we can calibrate models, and the better the predictions for the future will be from these models.
If you look at projections of sea level rise in the future, there are extraordinarily high errors on those. They're not good at all, simply because we don't know too much at all about how these, specifically these marine parts of the glaciers, how they're going to behave in a warmer climate. And trying to put the time on how much ice you can lose in a certain time if the temperature goes up is very, very difficult. And we have learned from our work that you really need to have field data to constrain the numerical modeling that you use to project the future. So one of the important part here is to get this field information.
So I hope that we find good answers that help us understand the stability of the northern Greenland ice sheet much better. And I'm also sure that we will come home with a lot of new questions, because this is what research is about. There is never an end to it.